In this screencast, I'm going to give you a brief description of how to use an interactive simulation that models a plug flow reactor. And what we're interested in here is what is referred to as parametric sensitivity. The idea of parametric sensitivity is, as I change the properties in the model, for example, as I change the heat of reaction, or the activation energy, or the heat transfer coefficient, then the behavior of the system will change. In this case, we're plotting the molar flow rate as a function of cumulative volume down the reactor. So we're looking at a series reaction. A goes to B, goes to C. They have different heats of reaction, different activation energies for each reaction, different pre-exponential factors. So we can change the rate constants. We can also change the inlet temperature. And part of the idea of parametric sensitivity is that when we develop a model for a system, because we don't know the values exactly, we should really look at what happens when we change the value slightly. For example, if we think the heat of reaction is minus 30 kilojoules per mole, and it's actually minus 33. How much does that change the behavior? For some things it's very sensitive, for other things it's less sensitive. So the idea of the simulation, it allows you to change these variables and then look at the behavior of the system. You can plot the molar flow rates as a function of cumulative volume. You can also plot the temperature, since this is a non-isothermal reactor, has heat transfer. The simulation location is given here on the Wolfram demonstration project site. So now we'll go and look at this simulation. So here's the interactive simulation for this plug flow reactor. Selected the molar flow rate button. I can select temperature and see how for this exothermic reaction the temperature increases, goes through a maximum, and then levels out. Let's look at temperature. If I change the heat of reaction, pretty small changes, change this heat of reaction, a little more change, so not very sensitive to heat of reaction. However, if I change the activation energy, now you notice rather dramatic sensitivity. And so this is the idea of this simulation. If we look at the molar flow rates as I change this activation energy, you can see the reaction occurs very early in the reactor. And so the idea is, of course, we're decreasing the activation energy, we're basically increasing the rate constant. And this is for the first reaction. So the idea is you can look at the effect of each of these parameters, and changing these parameters will change the behavior of the system, get a better idea of how good a model is, because if slight changes in a parameter causes rather dramatic changes in the system behavior, you have to be very careful as to how well the model is going to model the real system.